Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about search relevance. This topic is based on a tech blog with the title Fine-Tuning Llama 3 to Measure Semantic Relevance in Search, written by the data science team from Faire. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Faire is an online wholesale marketplace that connects independent retailers with unique and emerging brands. It is founded in 2017 and headquartered in San Francisco. Since then, the company has grown significantly, and as of 2024, it is valued at $12 billion. Faire serves two types of customers. One is independent retailers, and the other is wholesale brands. Independent retailers, such as local boutique owners seeking unique products to differentiate their stores. They rely heavily on Faire's search functionality to discover and purchase items. On the other side, wholesale brands, like artisanal candle makers or eco-friendly clothing lines, they use Faire to reach these independent retailers. To support both groups, Faire incorporates advanced algorithms and machine learning techniques into their search engine. These technologies efficiently categorize products and offer relevant search results. By doing so, Faire ensures the retailers can find exactly what they are looking for. This streamlines their buying process and increases overall satisfaction for both the retailers and the brands. As you can see, consistently improving search relevance is crucial for enhancing their business performance. To achieve this requires a clear and precise definition of what search relevance means in the context of the Faire's marketplace. Additionally, it also requires a continuously measuring of the relevance to assess their current performance. Using this assessment as feedback, the data team then can leverage this to refine and enhance the search algorithms. This ongoing process of evaluation and adjustment is a key challenge that the Faire's data team must address to ensure their search functionality meets the evolving needs of their customers. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see what is the team's solution. Before improving the relevance of search, a first step is always to properly define what search relevance even means. The team adopts the ESCI breakdown of relevance standard, as used in the previous KDD Cup in 2022 competition. At a high level, there are 4 tiers to define what is search relevance. Tier 1 is called exact. The return result is fully relevant to the query, and it satisfies all the query specification. For example, if the search query is plastic water bottle 24 ounce, then a water bottle matching all the stated attributes would be considered in the exact tier. Tier 2 is called substitute. The returned item is somewhat relevant, but fails to fulfill some aspects of the query. However, it can be used as the functional substitute of the search. For instance, if the search query is sweater and the return result is a fleece, it would fall into this tier. Tier 3 is called complement. The returned result may not fulfill the query, but it could be used as a complement to this exact item. For example, if the search is for running shoe and the return result is for a track pants, then it fits in this category. Tier 4 is irrelevant. The returned item is irrelevant and fails to fulfill a central aspect of the query. For instance, if the search query is for a microwave, but the return result is for a pillow, this is considered as irrelevant. As you can see, for these 4 tiers, they are exact, substitute, complement, and irrelevant. Their initials combines to the standard of ESCI. This tiering approach to quantify relevance is very important, as it provides the right granularity to fit downstream applications' needs. Sometimes, the search results do not always need to be exact, as that may lead to less serendipity, and those in the substitute or complement tiers can also be useful in related situations. Once the relevance is defined for the search, the next step is to measure and model the search relevance. This is quite challenging because the inherent subjectivity of the problem and the typical lack of ground truth for relevance for user behavior. The team approaches this challenge through the following 3 stages of their solution. The first stage relies heavily on human labeling. The team partnered with a data annotation vendor to label a sample of the query result pairs every month, mirroring the overall relevance of their search system. This provided an initial view of their search relevance and allowed the team to iterate on the guidelines and definitions for relevance measurements, especially for those edge cases which are hard to be identified and require iterations to improve. Although using human labeling was a good start, it was too expensive and not immediately actionable because there is always 1 month's delay between the measurement and the label availability. To make these relevance measurements more actionable, the team aimed to reduce cost and the lag time. They sought to leverage large language models as their next stage solution, because large language models have a strong pre-trained understanding of natural language, and they are particularly suitable for learning from a limited number of labels to robustly predict relevance. With this consideration, the team moved to the second stage of measuring search relevance. They leveraged a commercial GPT model and fine-tuned it to align with the human labelers' decisions on their search results. In this approach, they concatenated the search query's text with the returned product information, along with the brand name and the product category type, and using this as a prompt for this large language model. Then, this fine-tuned GPT was tasked with completing the text with 1 of the 4 relevance labels to measure the relevance of the search query and the product. The true north metric of this large language model's performance was compared against the agreement with human labeling results, and this is measured by Krippendorf alpha. The Krippendorf alpha score typically ranges from 0 to 1, where the 0 represents random agreement, and 1 represents complete agreement. Using this fine-tuned GPT commercial model, the team achieved a Krippendorf alpha of 0.56 and could label about 300,000 query results per hour when deployed to production. This allows them to start measuring relevance on a daily basis from limited samples. This is a significant improvement compared to the monthly manual approach. This daily measurement capability also helped the team to iterate their product and improve their search relevance. While on the other side, as their search system evolves, the use and dependence of this relevance label also increases. And this leads to a dramatic increased cost with this commercial GPT model. Given the concern on this high cost structure, in their latest modeling stage, the team turned to open source large language models that have state-of-the-art performance in various benchmarks. They focused on Meta's Llama family of models due to its performance and licensing for commercial use. The team tested various settings for the Llama series model, along with the different configurations, such as different training datasets, and then they identified the best performing version. Surprisingly, this open source solution performed much better in terms of the Krippendorf alpha metric compared to the commercial GPT version. It achieves 0.72 metric comparing to the 0.56, representing almost a 30% improvement of the performance. The team then hosted this selected Llama 3 model on their own GPU cluster to create batch predictions of those search relevance for new search sessions. And it is capable of making 70 million predictions per day using 16 GPUs. This is almost 10 times the throughput of the previous commercial GPT model, and with a much lower cost. After these 3 stages of modeling improvements, the current model guides the team in further iterating their search algorithm and improving their business objectives. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we discussed the importance of search relevance for the company Faire, how their data team quantifies semantic relevance in search, and how they iterated their solutions to eventually leverage open source large language models to measure those search relevance effectively at scale. If you like the content of the episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.